David Smith here with another Flipped Classroom math video. A few tips before we start. Remember that you can slow down or speed up the playback if that helps you follow along. You can also pause the video at any point to catch up with your notes or try the problems before I explain them. Lastly, you could turn on the captions and read my words going along below the bottom of the screen. Today's topic, graphs of exponential functions. So these functions have distinct graphs that are very different than quadratic functions. So let's get started. A couple things before we begin. Here's our basic function, f of x equals some base a to the x power. Now we have a couple conditions. One, we want a to be greater than 0. Okay? 0 doesn't make any sense because 0 to a power, it just doesn't do anything for us. So it needs to be positive. If it was negative, think about what happens. If we have an even power, the result is positive. If we have an odd power, the result is negative. So if we had a negative base, that function is going to be flipping back and forth over the x-axis as y goes from negative to positive. We can do that, but for this chapter, we're not going to go there. Okay, so that's this rule. A is a number that's greater than 0. The second one is we don't want a to be 1. Think about why that's not that interesting. If the base is 1, doesn't matter what the power is. It's just 1 times 1 times 1, however many times you have a power. So that function's not going to do anything. The y value is always going to be 1. So that's not very interesting either. Okay? So what that leaves is it leaves all the numbers greater than 0. So we can have our integers, 1, 2, 3, 4. We can have fractions. We can have like a half or 6 or things like that. Okay? All right, so let's take a look at this. We're going to graph a table of values for 2 to the x. This is our standard doubling function. It illustrates a lot of the properties of exponential functions nice and quick and nice and easy. All right, so I made a table of values here prior to graphing. We're going to graph this basic one on the board. Being able to make hand graphs is a really important skill in mathematics. We have tools, and I'm going to jump into Desmos in just a minute to show you a lot of variations quickly and easily. But you have to be able to make a hand graph. Okay, so table of values is a great way to start. I'm going to pick -3 all the way through 0 to +3 for my x value. So remember, that is my exponent here. My base in this case is 2. So when x is -3, that's 2 to the -3, which is 1 over 2 to the 3, which is 1/8. Okay? So that's what we would get for this one. That's 1 over 8. Now, -2 is a real similar thing, but it's going to be 1 over 2 to the 2, which is 1/4. -1 is going to give us 1/2. The 0 power, always 1. Now we have 2 to the 1. That's just 2. 2 to the 2 is 4. And 2 to the 3 is 8. So for a basic function like this, you'll notice a pattern that as we move away from 0 in either direction, if we're going in the positive direction, we get 2, 4, 8. We're doubling. When we go in the negative direction, we're halving. So the 2, 4, 8 is at the bottom of the fraction. Okay? So here's our table of values. Now let's make a graph. Now this is a step that students often struggle with. Look at your values so you know how to label your axes. Now one thing with our exponential functions is we're not going to get too many things below the y-axis. Certainly with this one, we have negative x values, right? So we're going to go left and right, but our y values are all positive. Some of them are kind of small, but they're still positive. So I'm just going to mark off my x, 1, 2, 3, and -1, -2, -3. Now my y, what am I going from? I'm going from 1/8, pretty teeny, all the way up to 8. So this is a little bit of a challenge, but we can do it. Let's get this up there a little further. I'm going to call this one 10, and then we can go, that's 5, 1, 2, 3, 4, 6, 7, 8, 9, 10. So that's a pretty good scale. It's going to certainly capture everything that we're doing in this graph. Okay, our first point, -3, 1/8. That point is like right here. It's above the x-axis, but not by much. -2, 1/4, same thing, just a little bit higher, but not by much. -1, 1/2, we're getting higher, maybe right about there. 0, 1 goes right through there. 1 is 2, so we're getting up here. 3 is, no, 1 is 2, 2 is 4, so that's getting up here, and 3 is 8, so we're up here. So you can start to see what this graph is doing. It's very small. It starts increasing by a faster and faster and faster rate. This is what a doubling function does. It increases quicker and quicker and quicker. So this is truly what we mean by exponential growth. A lot of people talk about quadratic equations, like y equals x squared, as exponential growth. Strictly speaking, that's quadratic growth. This is true exponential growth. So let's connect up make our line here. So this is f of x equals 2 to the x. And that's our graph. And you'll notice that as x gets more and more negative, our f of x is going to get tinier and tinier and tinier, but it's never going to get to 0 even. It's going to get really, really small. It's going to be 1 over some huge number, but it's still positive. So remember in the last lesson we talked about the range of some of these functions, specifically of this function. We said it's all real numbers greater than 0. And on the graph here, you can really see that. Okay, I'm going to ask you this question. What's the y-intercept? Look at your graph. If you still don't get it, y-intercept is the value of y when x is 0. So what's the y-intercept? If you got 0, 1, you're correct. So when you have a function like this, like 2 to the x, pretty basic, it's going to go through 0, 1. In fact, 3 to the x goes through 0, 1. 5 to the x goes through 0, 1. The graphs look a little different, but they all go through 0, 1. Okay? So let's jump into Desmos and see what some of these variations look like. Okay, so let's take a minute and pop into Desmos. We're going to quickly explore a bunch of variations of this basic exponential function. And this is a great tool that helps us kind of look at things fast without having to do all these hand graphs. So I love Desmos. Just make sure that you know how to use your hand graphs. Okay, here we are. I've already keyed in the basic doubling function. This is f of x equals 2 to the x. And you can see this looks fairly similar to the graph we had on the board not too long ago. And if you dig in and look at the points on this curve, they're the same curves that we graphed by hand. I'm going to zoom out real quick and notice that it never crosses the x-axis. It's still just above. Okay, so I'm going to put in another one here. Let's just make a room. We're going to call this one g of x. And we're going to do, let's try 3 to the x. 3 caret x. Whoops, I got it equals right there. Okay, so this is the blue graph. Notice how it's rising more steeply. Actually, it rises a little bit more shallowly when our x values are negative, when we have 1 over 3 to the x. And then once we pass through 1, it starts going much more steeply. Okay. Notice also how it's going through the point 0, 1. So the y-intercept is still that same point. Let's throw another one on there. How about h of x equals, I don't know, let's try 5 to the x. Check that one out. This is the green line. And guess what? It's still going through 0, 1, but it's rising much, much more steeply than 2 to the x and 3 to the x do. Just for grins, let's try j of x equals 10 to the x. And that's the purple one. And see how that one is even rising more steeply. So this gives you a feel for how these graphs look. When you're doing your exercises for this lesson, you can use Desmos to kind of check it out. But if it's asking for a graph, what I want you to do is translate that graph onto your paper. So make sure that you get the correct intercept and make sure that your graph is going through approximately the correct spots on there. So make sure your axes are labeled correctly and that your curve shows up in the right place. Okay, so a couple things about this. This is an increasing function, which means as x gets bigger, the value gets bigger, the f of x or the y value gets bigger. This specifically is modeling what we call exponential growth. So this is the kind of thing in science that you'll get if you put a couple cells in a petri dish and you let them grow, and let's say those cells doubled every 5 hours, and you graphed this, your graph would look kind of like this one. Let's take a peek at a couple other things. Oh, I have a question for you. How about the horizontal asymptote? An asymptote is a line over which a function never crosses. So this function does have that line. In fact, all 4 of these have that line. It's never going to cross the x-axis. So this function has a horizontal asymptote of y equals 0. And if you recall, the line y equals 0 is just simply the x-axis. Okay? All right. So let's take a look at a slightly different version of this function. Or actually, it's not slightly, it's actually fairly different. I'm going to go ahead and get rid of everything. And I'm going to put in y equals, or no, we're using function notation. So f of x equals, let's try 0.8 caret x. Whoa, now that's kind of different. Now let's take a minute and think about what we did. 0.8 is less than 1. So each time we raise the power, we're multiplying 0.8 by itself one more time. So it's 0.8 times 0.8 times 0.8. So as x increases, f of x is going to decrease. So this one is a decreasing function, and it can be used to model things in science like exponential decay, like radioactivity. If you have a hunk of strontium-90 and it's decaying at some rate, we call that the half-life, and that's the amount of time it takes for half of that unstable element to decay into a more stable element. So curves like this will model exponential decay, and radioactive decay is one form of that. Let's try another one. Let's try our g of x this time. Let's have that be 0.5 to the x, not 2 to the x. There we go. Forgot my equals. There we go. So now this, the red line here, this is decreasing more steeply. Okay, so again, we're getting a steeper and steeper function as our fraction, our 0.5, which is really just 1/2, gets smaller and smaller. Let's try one more. Let's try h of x equals 0.25 to the x power. And check that out. This one is even more steep. It's dropping really fast. And then let's do one last one. J of x equals, let's try 1/10, 0.1 caret x. And check that one out. That's the green line. This one is nice and big when x is negative, but when x goes positive, this one just drops down to 0 almost right away. Okay, so think about a few things. What do you notice? There are some similarities to our increasing function that we just explored a second ago. How about the y-intercept? Hey, check it out. It's the same, okay? It still goes through the point 0, 1. Now what happens as our base gets smaller, the graph gets steeper. How about the horizontal asymptote? Check it out. It's still the same. These graphs never cross the x-axis. So the horizontal asymptote is the line y equals 0, okay? So I want to back up just a sec. I want to get rid of this one, and that one. So this is 1/2 to the x. Let's just put 2 to the x back in there. So check this out. 1/2 is just 1/2, right? So these two functions are closely related. And check it out. They're basically mirror images of each other. 1/2 to the x is a decreasing function that decreases in pretty much the same way that 2 to the x increases. In fact, when we do this in the transformations chapter, later in your progression through mathematics, you're going to find out that this is a transformation of the basic doubling function, the halving function, which is 0.5 to the x. So that kind of makes sense. Okay, so that was a little Desmos treatment of our exponential functions, both increasing and decreasing. So please feel free to use Desmos. Just make sure that you can create accurate, meaningful, and good hand graphs. Now that you've finished watching the video, take a moment to jot down any questions you have so you can bring them to our next class and get some help. You can also watch the video again to perfect your understanding. If you enjoyed it, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.